All right, we're in section 6.4, where we're going to prove triangles are similar by angle-angle similarity, or AA. Angle-angle similarity postulate states that if two angles of one triangle are congruent to two angles of another triangle, then we can say that at least the two triangles are similar. All right. You only have to do that to show that proof by two angles. So in the uh, drawing or diagram presented to us, it looks like it says like angle J and angle X are congruent, and angle K and angle Y are congruent. So by saying that those two angles are congruent, we can say by AA similarity, triangle JKL is similar to triangle XYZ. All right. So all we have to do is show that two angles are congruent, then we can say that those triangles are similar. So we're going to have to use some rules from previous sections to help us out, but we should be able to do these things. So first off, we're going to determine whether the two triangles are similar. If they are, they want us to write a similarity statement, okay? So right off the bat, I look at it and I see at least one angle that's the same. I see I have a 90 degree and a 90 degree. I got a 26 and a 64. I'm not sure yet, but what we can do is this. I know, or we know, that because of the triangle sum theorem, that the interior angle of a triangle is 180 degrees. So to be able to determine what the other angle is, I'm just going to take 180, subtract it by 90, and subtract it by 26, which then gives me 64 degrees, which means I got a match here and a match here, and that's all I have to do. So since I've proven that two angles are congruent, I can say, yes, these are similar by AA, and then if they are so, write a similarity statement. The similarity statement I can use is triangle CDE is similar to triangle. Now I have to find this one would obviously be the 26 in this triangle. So it's going to be triangle K, and then D is 90, so that means that's going to be G over here, H. So triangle CDE is similar to triangle KGH. Okay. Looking at example B, I have two triangles contained in there. So I have a triangle right here, and then I have a triangle right here. Okay. So, whoops. Let's go back. Here, I won't erase those lines. But what we do have is EB is parallel to DC. So that does help us. For one, we can look at this angle here is congruent. So angle A is going to be in both triangles, okay? ADC and triangle AEB, all right? So angle A is going to be congruent to angle A by the reflexive property, okay? Kind of similar when we talked about with sides being congruent when they're contained in the, with the same side. Then, since these are parallel, I can say either one of these. So like angle EBA is congruent to angle DCA. And the reason why that's true, so I'm just going to say angle EBA is congruent to angle DCA because of the corresponding angles. All right, so I proved that angle A is equal to angle A, and angle EBA is congruent to DBC. So by AA similarity, I could say that triangle AEB is similar to triangle ADC. Okay. Looking at example C, another thing is SR is parallel to TU. That is going to help us. And they don't have any angles for us, but we know that these two angles are going to be congruent because I know that angle SVR is congruent to angle TVU because of vertical angles. All right, so vertical angles. Then you just get to pick. I know that angle R, SRV, I'm sorry, and angle UTV is congruent because of alternating interior angles. So since those two are congruent and the vertical angles are congruent, I can say yes, these are similar because of AA similarity. So triangle, let's take a look. So I'm going to say SVR is similar to triangle. And so here, so S and U don't have anything, so I'm going to say UT. Oh, I'm sorry. That's wrong. Let's try this again. So triangle SVR is similar to triangle UVT. Yeah. Okay. Let's go to the next page. Still the same rules apply. I need to find if they're similar. And if they are, write a similarity statement. Right off the bat, I have two angles that are congruent by their measure. And from the previous one, we know that those two angles are congruent because of vertical angles. So yes, these are true by angle. So I got two angles that are congruent. So triangle, let's say NMY is similar to triangle ZXY. And again, those can be in any order, just as long as they match up. So if I wanted to put the Y's in the middle, or the Y to start with, there's more than one way to write it. Looking at example E, I see I have two angles that are congruent with 35, but again, that doesn't prove anything yet because I got an 85 and a 65, but we do remember that the triangle sum theorem tells us that the sum of the interior angles gives us 180, so 180 subtracted by 35 and subtracted by 65. I'm looking at the triangle on the right, and it gives me 80 degrees here. Well, we were hoping that that would be 85, which means that only one angle is congruent, not two, and we needed two in order to prove similarity, so these triangles are not similar. Okay. Looking at this example, it says an air hockey player returns the puck to his opponent by bouncing the puck off the wall of the tables as shown. From physics, the angle that the path of the puck makes the wall are congruent. What is the distance d between the puck and the wall when the opponent returns it. So we got these two players and they have this triangle here, and we look at this triangle here where it would be 26 inches. This is 20 inches over here, and then this other triangle over here, I got D for a value. This is 90. These two angles are congruent. So since they're congruent, we also know that they're similar. And from previous sections said that when they're similar, their sides are proportional. So the distance from here to here, they don't really give it us directly, but I can say that 66 minus 26 gives us 40. So I can write a proportion to be able to solve for D. So I can say that this side will line up with this side here. So I can say that D over 20 equals, and since I put the larger triangle up top, I'll put the 40 over 26. Do the cross product, so I get 26D equals 40 times 20, which gives me 800. And dividing both sides by 26, that means D roughly equals 30 point, let's say 7, and it was inches. Okay, and that is being able to prove triangles are similar by angle-angle similarity. Hope this helps. Until next time.